Good morning, dear students. Welcome to Jatin's Academy. So, today in this class, we are going to start with the fifth chapter of class 6 ICSE Physics, that is light energy. So, in this class, we are going to study first of all sources of light, that is luminous and non-luminous objects. Then, we will discuss about transmission of light. Then, we are having rectilinear propagation of light. Then, we are having pinhole camera. We will discuss about construction and its working. Then, we are having shadows. Then we will discuss about umbra and penumbra. Then we will discuss about shadow formed by point source of light. Then we are having shadow formed by a light source smaller as well as larger than the object. Then we will discuss about eclipses. In last we are having two types of eclipses, that is solar eclipse and lunar eclipse. So let us start with the chapter. So very first topic we are having, what is light? As the chapter name suggests, light energy. So first of all, we should know the definition of light. So what is the definition of light? See carefully. Light is a form of energy which causes sensation of vision into our eyes. Means whatsoever objects or whatsoever things are present in our surrounding, how we are able to see that objects. So firstly, obviously with the help of our eyes, we are able to see that objects. Fine. But for example, if you are entering into a dark room where there is no light, even though your eyes are open in that room, okay, but if there is no light, then you are not able to see anything. Okay, so what do you mean by light? Light is that form of energy which enable us to see the objects which are present around us. Fine. So next topic we are having speed of light. What do you mean by speed of light? Speed of light means with which speed light travels in air, or you can say with which speed light travels in a vacuum. So this value you have to learn properly. Light travels with the speed of 3 into 10 to the power 8 meter per second, or if you want to write this value in kilometer per second, then this value you have to remember 3 lakh kilometer per second. Okay. Next topic we are having sources of light. So what do you mean by sources of light? See carefully. A source of light is an object which emits light. So whatsoever objects are present in our surrounding, the objects which are emitting light, these objects are nothing but sources of light. For example, sun is there. The main source of light on the earth's surface is the sun. Okay. And for example, glowing electric bulb is there, fluorescent tube is there, CFL bulbs are there. So whatsoever things are emitting light in order to enable us to see the objects around us are known as sources of light. So next topic we are having luminous objects. So what do you mean by luminous objects? Here we are having the definition. Luminous objects are those objects which themselves emit light, or the objects which produce their own light are known as luminous objects. For example, the sun, the stars, electric lamp, burning candle. So these materials or these objects are emitting their own light, no? So these are known as luminous objects. Next topic we are having non-luminous objects. So what do you mean by non-luminous objects? As the name suggests, non-luminous objects. Non-luminous means the objects which do not have its own light or which do not produce its own light is known as non-luminous object. For example, these are the books. Books are emitting their own light. Obviously no. For example, table is there. Table is emitting its own light. No. And similar example, for example, we are having earth, moon. Yes, moon also. Whenever you are watching the moon, you will say that yes, moon is emitting its light. But actually the answer is no. Moon is not emitting its own light. So how we are able to see the moon as a shiny object? Why moon is a shiny object, or why it appears to send a light to us? Whenever the sun radiations fall on the moon, that sun radiations reflect back and comes into our eye. That is why we feel moon as shiny. But actually moon is not emitting its own light, and moon is regarded as non-luminous objects. In a similar manner, for example, satellite, table, chair, books, these all things are non-luminous objects. Now my question is, if non-luminous objects do not produce their own light, then how we are able to see the non-luminous objects? So here we are having the answer. For example, here I am having a rose, and rose, as you know, is a non-luminous object. So how I am able to see the rose? So whenever we are having the luminous object in contact of the non-luminous object, means near the non-luminous object, when we are having the luminous object, what this luminous object is doing? This luminous object is sending its light in all directions. As we know, sun is emitting its light in all direction. But if I am considering one ray of light and it is just striking on a non-luminous body, after striking on the non-luminous body, this ray of light will reflect back into our eyes, and with that, whenever these light rays entering into our eyes, we are able to see the image of that object. With the help of luminous body, we are able to see the non-luminous body. Clear? So here we are having the definition. When the light from the source of light, for example, here we are having a luminous body, and when the light from a source fall on a non-luminous objects, it gets scattered in all directions. Into the non-luminous objects, whenever light is striking by the luminous object, it's scattered into all directions, and one of the light ray, when it enters to our eye, it appears or it shows us the image of that non-luminous object into our mind. That is why we are able to see the non-luminous objects whatsoever are present in our surrounding. Next topic we are having transmission of light. So what do you mean by transmission of light? Transmission of light means whatsoever things are present in our surrounding or whatsoever objects are present into our surrounding, that objects are categorized into three categories. Why they are categorized into three categories? On the basis of transmission of light. Actually, some objects are there which do not allow any light to pass through it, or some objects are there which allow full light to pass through it, or all the light radiations to pass through it. Okay, and some objects are there which allow only some light to pass through them. So that is why we are just categorizing the objects into three categories. Very first we are having opaque objects. So what do you mean by opaque objects? Those objects which do not allow the light radiations to pass through it. For example, I am having here wall. So if I am striking the light rays on the wall do not allow the light rays to pass through it, na? It will not allow the light rays to pass through it. That is why this wall is regarded as opaque objects. In a similar manner, for example, we are having books, wood, steel, bricks. These all things are opaque objects which do not allow the light to pass through them. Second type we are having transparent objects. So what do you mean by transparent objects? The objects which allow the light to pass through them. For example, this I am having a glass. Whenever I am striking the light rays on a glass, the glass will allow full light to pass through it. So what glass is regarded as? Glass is regarded as transparent object. So examples of transparent objects are glass, water, alcohol, etc. These all things are transparent objects which allow the light to pass through it. So third category we are having of translucent objects. So what do you mean by translucent objects? The objects which allow the light to pass through them but partially. Means it does not allow the full light or all the light radiations to pass through it, but it allow only some radiations or partial radiations to pass through it. That is known as translucent objects. For example, we are having ground glass, oil, fog, mist. These all materials are translucent objects which allow only some light radiations to pass through it. So next topic we are having rectilinear propagation of light. So what do you mean by rectilinear propagation of light? Here we are having the definition. In a transparent medium, light always travels in a straight line. Means, for example, here we are having any transparent object. Here we are having glass, here also glass, here also glass, and in front of transparent medium we are having a source of light. So whenever light from the source of light is entering into a transparent object, that transparent object will allow the light to pass in a straight manner or in a straight line. And this property of the light, whenever it is moving in a straight line, is known as rectilinear propagation of light. And whatever the applications of rectilinear propagation of light are there, many phenomena are there, like formation of shadow, images are formed due to the rectilinear propagation of light. Even though solar eclipse and lunar eclipse, maybe you have listened the words like Surya Grahan and Chandra Grahan. These two things are there, known as solar eclipse and lunar eclipse. These things are also occur due to the rectilinear propagation of light. And about the formation of shadows, formation of images, solar eclipse, lunar eclipse, these all things we will study in the last slides of this chapter. Okay. So next topic we are having ray of light. What do you mean by ray of light? Ray of light is a very narrow path of light. Actually, it is a very narrow path of light which is represented by a line. First of all, here we are having the line with an arrowhead. Why this arrowhead is there? This arrowhead is showing the direction of the ray of light, means in which direction this ray of light is moving. So this arrowhead is showing the direction, and ray of light is very a narrow path of light. It is represented by a line. Okay. If we are collecting the rays of light, then that rays of light will form a beam of light. And here also, whenever beam of light is there, for example, here we are having point source of light. Very small source of light is there, and from the small source light radiations are scattering in all directions, and this one light radiation we will regard it as ray of light. Next topic we are having beam of light. So what do you mean by beam of light? A broad collection of light rays. Whenever we are taking up many light rays together, these together light rays will form a beam of light. So beam of light can be categorized into three types. Three types are there: parallel beam of light, this is a parallel beam of light. Second, we are having convergent beam of light, and third, we are having divergent beam of light. So one by one here we are going to study about parallel beam of light, convergent and divergent beam of light. Okay, so very first beam of light we are having parallel beam of light. What do you mean by parallel beam of light? See carefully. Whenever all the rays in a beam are parallel to each other, so these all rays are parallel to each other. So whenever in a beam of light rays are parallel to each other, that beam is known as parallel beam of light. In a similar manner, we are having divergent beam of light. Divergent means to go away from each other or to spread into all directions. So what is the definition? When the different rays of light beam move away from each other from the one source. For example, here we are having one source of light, and from the one source of light, light radiations are moving away from each other or scattering in the all directions. That is known as divergent beam of light. And third, we are having convergent beam of light. Convergent means to meet at a one point. Whenever many number of light rays are there, and they are meeting at one point, and this collection of light rays is known as convergent beam of light. Means from the different sources light rays are coming and meeting at one point. This is known as convergent beam of light. Next topic, we are having point and extended source of light. So what do you mean by point source of light? As a name suggests, point. Point means a source of light of the same size as the head of common pin. For example, we are having a pin, and whatsoever the size of their pin is there, whatsoever size is there of the pin, same to this size we are having the size of the source of object. If I am having a source of light very small size, this is regarded as point source of light. Okay, and here we are having the diagram for the point source of light like this. Very small source of light, and this much small that it can be taken as the size of the common pin. Okay, so it is known as point source of light. And in a similar manner, we are having extended source of light also. Extended source of light means the source of light whose size is bigger as compared to, here we are having whose size is bigger as compared to point source of light. So this point source of light is also emitting light, and here we are having extended source of light which is also emitting the light. Point means very small source of light. Extended means large source of light as compared to point source of light. Clear? Next, we are having images formed by a mirror. So how whenever object is standing in front of a mirror, how image is formed behind the mirror. So see carefully. For example, first of all, this we are having a plane mirror which is silver polished from back side, and from the front side it is a reflecting surface. So for example, this point object is standing in front of a plane mirror. So see how carefully how that images are going to form by a mirror. So whenever object is there, that object is going to send the light radiations to the mirror. Okay, when the light rays start from a point object, after the reflection from mirror, they are going to reflect back. Okay, by making a normal on a reflecting surface by equal angle of incidence, and here angle of reflection is there, they are going to reflect back and they are going to move like this. Means they are going to diverge into different directions. And when these reflected light rays will meet or appear to meet at one point, means here when these diverging light rays will meet or actually they are going to meet behind the mirror, then you can say that image formation is there. But here you can see these divergent light rays are not going to meet anywhere in a real world. So these divergent light rays are going to converge or meet at one point behind the mirror, and this one point where they are going to converge with each other, this point is known as image formed. So this is an object standing in front of plane mirror. This is an image formed in front of a plane mirror. Okay. Next, we are having types of images. So there are two kinds of images. First, we are having real image. Second, we are having virtual image. So what do you mean by real image? See carefully. As a name suggests, real image. Real images means those images in which reflected light rays actually meets in a real world. Okay. Whenever we are having a mirror and whenever we are having an object, after striking these light radiations on a plane mirror and after getting reflect back, if these light radiations will actually meets at one point, actually meets in a real world, then we will see that it is a real image. But here in a case of plane mirror, they are not going to meet at one point because these divergent light rays will never meet in a real world. So here they are going to converge, or they are going to meet behind the mirror. Okay, so this behind this, whenever the reflected light rays appears to meet at one point, this image formed behind the mirror is known as virtual image. This is the difference between real and virtual image. Now you will say that in which cases the real images are formed, that you will study in the class 8 about the concave and convex mirror. In a case of concave and convex mirror, images are going to form in the real world also. That images are known as real image, but in this class you will make the images in a virtual image only, means this diagram only you have to learn. Okay, I will show you one example also in daily life where real images and virtual images are formed. Real images are always formed in cinema halls. Whenever we are going to cinema hall, that cinema hall screen is showing us real image. Means there all the reflected light rays are meeting on screen only. Means they are not meeting behind screen. They are meeting on screen only. But in a virtual image, for example, you are standing in front of plane mirror. In front of plane mirror, these light rays are not actually meeting on mirror only, they are meeting behind mirror. Okay, behind mirror, that is why we are watching our image behind the mirror, not on mirror. Means whenever we are moving back also, the image is also moving back like this. Okay, so the image formed behind the screen, that is virtual image. The image formed on screen, that is real image. Clear? And here we are having difference between real and virtual image. Light rays after reflection actually meet at one point. Means if light ray after reflection actually meeting at one point, that actual meeting of one point is known as real image. But if light rays after reflection do not meet actually at one point, but we have to extend it, they are just extending or meeting at one point, that image formed is a virtual image. Real image is always inverted. Inverted means upside down. Upside down image is always formed in a real image. Then you will say, why not in a projector or in a cinema hall inverted or upside image is formed? Because this projector is also already kept in a inverted form. This projector they are already keeping in a upside form, so that image form will be correct image. Otherwise, if they will putting it in a straight way, then image formed is to be upside down. That is why they are using the opposite. Okay, so real image formed is always inverted image, and virtual image is always erect. Erect means up straight, upright image. Okay, whenever you are standing in front of plane mirror, wherever your head is there, that in image also your head is that position only, it is not going to invert. Okay, or your head is down and your toe is up, no. So here image formed in a virtual image is always erect, and real images are always inverted. Next we are having real image can obtained on screen. Real images are obtaining on screen because in a real image, reflections actually meeting at one point, reflected rays actually meeting at one point, and virtual image always formed behind the screen. Okay, next we are having examples. Image formed in a cinema hall is a real image, and image formed in a plane mirror is a virtual image. So next topic we are having applications of rectilinear propagation of light. As we have already studied about rectilinear propagation of light. So what do you mean by rectilinear propagation of light? Rectilinear propagation of light means the property of light in which light moves in a straight line through the transparent medium. This property is known as rectilinear propagation of light. And due to this property, there are three formations are there, or three applications are there because of this. First application is pinhole camera. Second application, we are having the formation of shadows. Shadows also form due to rectilinear propagation of light. And third, we are having occurrence of lunar and solar eclipse, or you can say Surya Grahan and Chandra Grahan. Okay. Principle of pinhole camera is rectilinear propagation of light. Formation of shadows principle is also this, rectilinear propagation of light. And the occurrence of solar and lunar eclipse principle is also rectilinear propagation of light. And this question is very important from exam point of view. Question will come like this. On which principle pinhole camera works? Answer will be this. On which principle formation of shadows form? Answer is rectilinear propagation of light, and same with the third, lunar and solar eclipse. So now one by one we are going to study all these the applications of rectilinear propagation of light. Firstly, we are going to start with the pinhole camera. So here we are going to study about the pinhole camera. So what do you mean by pinhole camera? See carefully. So whatsoever camera we are using in our daily life. So what this camera is doing? What the camera is doing? Camera is just clicking our picture, or we are taking the selfies from the camera. Okay. So this pinhole camera is also a type of camera, but it is the simplest type of camera, and the simplest type of camera is which? Pinhole camera. So what is a pinhole camera? See carefully. Why it is used? Pinhole camera is used to obtain the image of an object through the very small hole, or you can say through the pinhole. Means through this pinhole, whenever we are using the cardboard, and with the cardboard we are having very small hole, from the small hole we are able to take the picture or image of the object. And how it is working? It is just working on the principle of rectilinear propagation of light. When light travels in a straight line, only according to this principle pinhole camera works. If light travels zigzag, then there is no working of pinhole camera. Pinhole camera does not work properly in that case. Okay. So now we are going to study about the construction of pinhole camera. So actually a pinhole camera consists of a rectangular box. In a pinhole camera, actually rectangular box is there. At the one side of rectangular box, one film is there. Film, or you can say screen is there. Screen is there on the one side, and on the other side we are having a small hole. Okay. Opposite to the film, opposite to the screen, we are having a small hole. This film is acting as a screen which is inside the box. Inside this rectangular box we are having a screen, and this box is blackened inside. All the surfaces or all the sides of the whole rectangle is blackened. Why it is blackened? So whatsoever light radiations are entering into the rectangle, that all light radiations are going to absorb into it, and whatsoever image is there, that image is going to form into the screen. This is the construction of pinhole camera. So next topic we are having working of pinhole camera. So how pinhole camera works, how it is able to capture the image of an object. So actually in a pinhole camera, first of all object must be there. If there is an object in front of pinhole camera, then only the image will form on the screen. Okay. So how the image is forming? See carefully. So first of all, a beam of light from the top of the object passes through the pinhole and move toward the bottom of the screen like this. Whenever the light radiation from the top of the object moves through the pinhole and enters into the bottom of the screen, and similarly from the bottom of the object, when in a straight line, light ray will move from the pinhole and moves up toward the upside of the screen, it will form the image. Okay, in this way image is formed. But whatsoever image is forming on the screen, that image is upside down. Actually object is like this, but image formed is like this, or you can say inverted image is formed. Inverted means upside down image is formed, and the image is forming on screen. No? So whenever I told the images are forming on screen, that images are nothing but real image. So in pinhole camera, first of all inverted image is formed, and secondly image formed is a real image, means the image which forms on screen. So this is the working of the pinhole camera. Next we are going to see that on which factors size of the image formed by a pinhole camera depends. So mainly there are two factors on which the size of image formed by a pinhole camera depends. So very first factor we are having, it depends upon the distance of screen from the pinhole. Means whenever we are changing the distance from the screen and that of pinhole, the size of the image formed by a pinhole camera also changes. First factor we are having this, and second factor we are having, it also depends upon the distance of screen from the object. Means whenever we are changing the distance from the screen, that of object, in that case also size of the image is going to change. So here we are going to study about the first effect, that how the distance of the screen from the pinhole on the size of the image depends. So how it depends, see carefully. If the distance of the screen from the pinhole is increased, for example this is, we are having simple pinhole camera. In simple pinhole camera this kind of image is formed. But yes, if I am increasing the distance from the screen and that of pinhole, this distance I am going to increase like this. So here distance increases. Whenever we are increasing the distance from the pinhole and that of screen, in that case size of the image is going to enlarge or increases. By increasing the distance, size of the image is also going to increase. Second method we are having, we can change the distance of the pinhole from that of object. Means if the for example this we are having simple pinhole camera, and whenever we are changing the distance or whenever we are increasing the distance from the pinhole to that of object, in that case the size of the image is going to decrease. Okay, increasing the distance between the pinhole and the object, size of the image decreases. So now here we are having the formula that how we can find the size of image formed by a pinhole camera by using which relation. So here we are having the relation. This relation we can use in order to check the size of the image. Okay. So this relation is like this: size of image over size of object. What is the size of image? That we have to write upside, over size of object we have to write downside, is equals to, here you have to write the distance of the screen from the pinhole, and downside in the denominator you have to write distance of the object from the pinhole. So by using this formula we can easily find the size of the image formed by a pinhole camera. This relation only you have to learn. Just you have to learn the formula, as in 6th class there is no numericals related to this. Okay, just learn this formula. So next topic we are having shadow. So what do you mean by shadow? Might be you have seen these kind of shadows in your daily life. So what is a shadow? Shadow is a darkness caused by a opaque object. For example, whenever we are having a source of light and in between the source of light one opaque object is there. So what this opaque object will do? Opaque object will block the light rays into it. It will not allow the light rays to pass through it. So whenever light rays are going to block by the opaque object, in that case shadows form. And shadows always need a screen in order to make. Clear? The shadow is only the darker region of the opaque object. Black or grey color is there of the shadow, which does not contain any color and does not give any information about the object. So during the formation of a shadow, three conditions must be fulfilled. What are these three conditions? See carefully. First of all, we should have a source of light. If there is a source of light, in that case only shadows are formed. Even though if we are having point source of light also, in that case also shadows are formed, and shadows are formed very like proper shadows are formed by a point source of light. Second condition is an opaque object must be there. In between the light rays of the source of light, there should be an opaque object. That opaque object will block the light rays, and after blocking the light rays, there must be a screen where the shadows are going to form. Screen must be there. Whenever screen is there, in that case whenever opaque object is going to block the light from the source of light, the blocking of the light ray by the opaque object will cast a shadow on a screen. So three conditions must be fulfilled. In that three conditions only the formation of shadow will be there, otherwise no shadow is there. So now only we have studied about the shadow. Actually whatsoever shadows are there, that shadows always contain two parts. What are that two parts? First part is we are having umbra. What do you mean by umbra? For example, here we are having a source of light, and in between the source of light and the screen we are having a opaque object. Whenever the light rays from the source of light are going to strike on the opaque object, these light rays are going to block by the opaque object. Whatsoever light rays are going to blocked by the opaque object, in that case umbra, or we can say darker shadow, is going to form. That darker shadow is nothing but called a umbra, and these light rays are there which are going to partially move from the opaque object. Means these light rays are not going to block by the opaque object. Whenever light rays are partially moving from the opaque object, in that case lighter shadows are formed, and these lighter shadows are known as penumbra. So what do you mean by umbra? Umbra is the inner part of the shadow which is completely dark. This is known as umbra, and actually no light reach in this umbra region. But if we are talking about penumbra, penumbra is a partial darkness. Might be you are seeing this partial darkness. Actually partial darkness is surrounds the umbra. In the surrounding of umbra we are having the penumbra, and here in the penumbra region some light rays always reach in this region. So next topic we are having shadow formed by a point source of light. For example, when we are having a point source of light, what kind of shadow is going to form by a point source of light? So in a point source of light, these kind of radiations are going to move. These kind of light radiations are there. So in a point source of light, actually whatsoever light radiations are there, these all light radiations are going to block by the opaque object, because in a point source of light few light rays are there, and these few light rays are going to block by the opaque object. Whenever all the light radiations are going to block by the opaque object, in that case full-fledged umbra is there and no penumbra is there. Okay, so whenever a light coming from a point source of light falls on an opaque object, the shadow is uniformly dark. Means from the upside till the downside uniformly dark shadows form, and there is a sharp edges at the end of umbra. Only sharp edges are there. Means here also like this, and here also same kind of shape is there. As the shape of object, same shape of the shadow or umbra is going to form. And here in this case, whenever from the point source of light shadow is going to form, in that case only umbra forms, but here penumbra is absent. Next topic we are having shadow formed by a light source smaller than that of object. If we are taking smaller light source and we are taking larger object, what is going to happen in this case? See carefully. Actually, in this case, both umbra and penumbra are going to form. For example, here I am having a opaque object which is larger as compared to the source of light. Here I am having source of light smaller as compared to the opaque object. Whenever the light radiation from the point source of light is going to fall on an opaque object, in this case both umbra and penumbra forms. Okay, both umbra and penumbra is going to form whenever we are taking the smaller source of light as compared to the opaque object. But yes, if we are taking the screen away from that of the opaque object, in that case both umbra and penumbra is going to increase. Here you can see whenever we are taking the screen away from opaque object, whenever we are having small source of light and the opaque object we are having larger, but in this case I have took the screen backside, means distance increases. Okay, so in that case umbra as well as penumbra size is going to increase. So now in this case I am going to take the opposite, means I am going to see that how shadows formed by a light source larger than that of opaque object. See carefully, whenever I am taking the larger source of light, here I am having larger source of light and opaque object I am having smaller. So in that case what is going to happen? In this case also both umbra and penumbra is going to form. Here also umbra is there and penumbra is there, but you can see the size of umbra is small than that of penumbra. Umbra is small and penumbra is large. This is a penumbra, outer region. Partial darkness is more and inner darkness is less, or umbra is less. Okay, so but whenever I am taking the screen away from that of opaque object, in that case the size of umbra means very much decreasing, gradually decreasing. Whenever I am taking screen away from that of opaque object, in that case umbra is going to decrease very much and penumbra increases. And now in this case I took the screen very away from that of opaque object, means here also I am having a larger source of light, here also I am having a larger source of light, but in this case you can see umbra is there and little bit penumbra is there. Okay, umbra and penumbra both are there, but if I am taking the screen very much away from that of opaque object, in that case, so here in this case if I am taking the screen very much away from that of opaque object, see carefully what is going to happen here. So beyond the point, whenever I am taking the screen very much away from the opaque object, here the size of umbra is going to decrease very much, and whenever we are taking screen away and away from the opaque object, in that case penumbra become too much large, and when it become too much large means here penumbra is going to faint, or it is not going to visible that much. Because of this reason only, whenever birds or aeroplanes are flying in the sky, we are not going to see the shadow on the earth's surface. Why? Because they are very far away from that of the screen, or the source of light is very far away from that of object and the screen. That is why the penumbra or the umbra is very much faint or too much large. If they are too much large, we are not able to see that much shadow cast on the earth. Okay. So third application of rectilinear propagation of light, we are having eclipses. So what do you mean by eclipses? See carefully. As we know, earth is always rotating or revolving around the sun, and moon is always revolving around the earth. And one phase is there when these all sun, moon and earth, they comes in a straight line. Whenever earth, sun and moon comes in a straight line, in that case the moon, either moon casts the shadow on the earth or sometimes earth casts the shadow on the moon. In that case, whenever there are some shadows formed on either earth or either on the moon, in that case eclipses are formed. So here we are having the definition for the eclipse. Eclipse means the formation of shadow of heavenly body on the other is called eclipse. Means whenever during the time when sun, moon and earth come in a straight line, in that case see carefully, whenever for example moon is coming in between earth and the sun. Okay, so here sun is acting like a source of light. So whenever in between the source of light and the screen one opaque object is there, obviously opaque object is going to cast its shadow on the screen. So in that case what forms? In that case eclipses are formed, or you can say the shadow cast by the earth or the moon is known as eclipses. So see carefully, according to this we are having two types of eclipses depending upon the position of sun, moon and the earth. Two type of eclipses are there, solar eclipse and lunar eclipse. In Hindi we are saying that Surya Grahan and Chandra Grahan. So here we are having the image for the lunar eclipse and this is the image for the solar eclipse. So now one by one we are going to study about the solar and lunar eclipse. So now we are going to study about the solar eclipses. So what do you mean by solar eclipses? So during the revolution of the moon, the sun and the earth, whenever this phase comes, that moon comes in between the sun and the earth. So here in this position, sun is acting like a source of light, moon is behaving as an opaque object and earth is acting like a screen. So whenever the light radiations from the sun is going to pass from the moon, so the moon is going to block the light radiations from the sun? Whenever the moon is going to block the light radiations from the sun, the moon is going to cast its shadow on the surface of earth. So whatsoever light radiations are coming from the sun and going to fall on the moon, whatsoever light radiations are totally blocked by the moon, in that case umbra region is going to form. And whatsoever light radiations are going to move partially from the moon, in that case penumbra region is there. This is penumbra region, this is umbra region. And the region of the earth which is under the umbra region, that region is known as total solar eclipse. In this case, in this part of the earth, total solar eclipse is there, and the region of the earth where there is a partial light, or you can say penumbra is there, in that case you can say partial solar eclipse is there. Okay, and this region is always, this umbra region is always observed on new moon day only. So next we are having lunar eclipses. So what do you mean by lunar eclipses? When earth come in between the sun and the moon, in that case lunar eclipses are there. So here sun is acting like a source of light, earth is acting like a opaque object, and moon is acting like a screen. Whenever the light radiations from the sun is going to fall on a surface of earth is blocking the light radiations from the sun. So whatsoever total light radiations are blocked by the earth's surface, in that case umbra region is there on the moon. And whenever moon is there in the umbral part, you will say that there is a total lunar eclipse. Okay, so next we are having, as long as the moon is the umbral region or umbra region, you will say that here is a total lunar eclipse. And when the moon is entering in the penumbral region, in that case you will say that partial lunar eclipse is there, and this lunar eclipse is always observed on full moon night only. So next our question is, can we see the eclipses with naked eyes, like this lunar eclipse or solar eclipse? Can we see with a naked eye? Naked eye means without wearing any glasses or all, we can see the lunar or solar eclipse. Our answer is, we can see the lunar eclipse directly. No problem, lunar eclipse we can directly with our naked eyes, but solar eclipse we cannot see with our naked eye, because solar eclipse are always forming too much light radiations or harsh light radiations which cannot be beared by our eyes. That is why either we have to use the goggles, or we can use either pinhole camera also you can use in order to see the solar eclipse, or you can use the x-ray sheets in order to see the solar eclipse. So next our question is, do other planets and satellites also form eclipses? So whenever the satellites come in between the sun and the earth, or it comes in between the sun and the moon, satellites and planets also cast the shadow in the space. So planets and their satellites also form eclipses. So this is all about your chapter number 5th, that is light energy of class 6 ICSE Physics. If you like the explanation, please like it, share it and subscribe our YouTube channel. Thank you so much.